Okay, so thanks so much all once again. Friday afternoon, almost. So I thought we'd start with something which is quite a bit more interesting than presentations, okay? So here at Dell, I wanted to introduce to you a facet of Dell that very, very few people know about, but it resonates very closely to manufacturing. Because at the end, the edge, as we started with the previous discussion, okay, is incredibly diverse, exceedingly unpredictable. So we've got to be prepared for pretty much everything. And this video basically shows you exactly how we do that. Okay, so gentlemen from Reliance, we just had a conversation. So sir, this is something that you might find very, very interesting. Can we please have the video?
When it comes to our rugged machines, just passing the industry.
Okay, I was afraid that that would happen. Sometimes things get a bit more complicated than they unfortunately are. Just give us a quick moment. So what we try to do here essentially is to test. Yeah, go ahead. Perfect. Thank you.
When it comes to our rugged machines, just passing the industry standard really isn't a product that's rugged enough for our customers. Here in the Rugged Test Lab, we test to fail.
Because our customers work in environments where incredibly unpredictable things can happen, they need to know that rugged products can do what they need them to do, wherever they need them to do it. The range of equipment that we have in this lab allows us to simulate all the difficult conditions that customers will experience. We need to know that these products can survive and thrive and allow productivity wherever customers are.
The thermal testing chamber exposes rugged machines to extreme temperatures. We go down to negative 29 degrees Celsius or negative 20 degrees Fahrenheit. What's important there is spinning media won't move. I've been in negative 20 degrees Fahrenheit weather. I didn't want to wait for anything, much less my computer. For our extreme heat testing, we want to make sure that the technology runs at 145 degrees Fahrenheit. For us, a pass is the computer is still on and you're not throttled at all. Our competitors can't make that statement. Our water ingress tests are designed to simulate harsh, wet environments. One of the most extreme water tests we perform is a water cannon that blasts machines at over 3 gallons per minute. In fact, we can turn this thing up full blast and it's still going to pass that test. Our dust protection chamber helps us ensure that sand, dust, and debris won't slow you down in the field. So what you're testing is, can you actually suck dust through your mechanical seal into your electronic compartment? One speck of dust is a fail. We're going to do drop testing. Something the shape of a computer has 26 different orientations that you can actually hit from. So we start at 4 foot, we go to 5 foot, and then we go to 6 foot. We're going to make it through all 78 of those drops with just 1 unit. I don't think any of us were dreaming that we were going to be at 9 and 10 feet dropping these units. So as much testing as we do in the lab, sometimes we just can't get it to fail. And when that happens, we have to get creative. We have a dedicated team of engineers with one goal in mind, and that is to break these products. And I'm going to be honest, that's getting harder and harder every year. The people using these products, firefighters, police officers, ambulance drivers, the military, they have hard jobs. That's why we've dedicated ourselves to finding the point of failure in the rugged test lab, so our customers never have to experience it out in the field.
So thank you so much. So that's a lot of the cool stuff that our colleagues basically subject not just the machine that you just saw, but a lot of servers and edge gateways that were discussed by Vikas, Hari, and Raj. So very quickly, We were talking about the Industrial Revolution. I'm not going to spend too much time on it, but I just wanted to call out how it is different, okay? So first, we started with steam engines, manufacturing processes. Before this, in fact, before the first Industrial Revolution, we were consuming equipment, clothing, food, which was grown within probably a 10 or 20 kilometer radius, right? Right now, with the advent of the steam engine, manufacturing processes in factories, things started to change. We started having import and export. Before this, it was not even possible. Then we started doing assembly lines where we started doing mass production, okay? So we basically tried to reduce the cost, bring predictability to the overall supply chain as well as manufacturing, and improve quality, okay? Then finally came in 1960s, semiconductor, the internet, robotics, automation, things of the other nature where you could basically talk to pretty much anyone, okay? Nostradamus once predicted that there would be a time when a human being could basically communicate with another human being, okay? Standing at two divergent corners of the planet. And people thought he was crazy. Now we have cell phones, augmented reality. And then, of course, we have the fourth Industrial Revolution and beyond, where you're going to be connecting pretty much everything that can be connected. In fact, previously, when I was at Ericsson, we used to say, we're going to be collecting 20 billion devices, okay? So that's essentially what's really going to happen, right? So what is all of that going to result in? So IDC, these are IDC estimates, November 2018. What you see is a phenomenal growth in terms of how data has been, increasing, how much data we are generating as humanity through 2025. These are 2025 estimates which were made in November 2018. But because of COVID, we strongly feel that we've already surpassed this, okay? What we're looking at is 175 zettabytes. And how much is that? It's 1 trillion gigabytes. That's just insane. And what is generating all of this information? It's basically IoT devices, telemetry and sensor data. And while a lot of us would think, hey, this is just 4 bits, 8 bits information, I'm afraid that's not true. Because sometimes you'll have some PLCs which are just showing you an on and off state. Some sensors will basically be giving you, okay, here's the temperature, right? But then you'll have thermal cameras. You will have cameras which are going to be looking at how welding is being done, because the welding arc is just too bright for the human eye. And those could be 4K cameras. Okay, that could be live streamed to an edge server, which unfortunately you can't really process with an Arduino machine. You will need something fairly beefy, right? You will have troop movement information, okay, through satellite imaging. That cannot be processed, okay? You will have information from processes, okay, in terms of a brewery, okay? You've got a bunch of sensors and you want to monitor the yeast content in some beer. I know it's a Friday afternoon, so I'm getting a little bit carried away, but pardon me for that. So what we're looking at is that a lot of this data is going to be stored on the cloud. 30% of this will be consumed in real time. And when I say 30% it's going to be consumed in real time, you want to act on this data in real time as well. And for that, you need edge computing. And what they're also saying is interactions per person per day are going to be increasing. They have already increased. I do not remember the last time I actually went to a brick and mortar store and bought rice, cereal, eggs. I get them delivered, right? I pay for them from my digital wallet or from my credit card. I haven't gone to an ATM in the last 2 years. Okay, so it's pretty crazy. And of course, all of this is going to be fueled by 5G and other Wi-Fi WAN technologies, right? The market is expected to reach $1.5 trillion, and these are again 2018 estimates. I presume this is going to be close to 2 or perhaps even surpass $2 trillion by perhaps before 2025. So what are we doing? We're looking at analyzing millions of data points from PLCs, connected to a manufacturing network in real time, okay? Improving yield, improving quality, and optimizing logistics. So let's see how that really comes into action. So you've got solutions to modernize all possible use cases. We basically saw how tough we are on the products that we manufacture and you put in your critical infrastructure. But the products are not really just physically immune to the elements. They are also incredibly secure, and security is a vital part of our DNA. We will discuss that in newer slides that follow, but essentially this gives you a broad level of understanding in terms of what diverse use cases could essentially be. Now, while it is impossible for me to fly customers from multiple locations, but some of you are already customers of Dell Technology. But what we've done is we've captured some customer testimonials, and I would want you to have a look at them. They speak for themselves in terms of the work that we do with them in building solutions that we co-build with them, we co-architect solutions with them. So with that other part, so you basically saw these use cases, and then what you see is, of course, a snapshot of that video. I'm not sure whether you're able to see these icons here. So what our products are subjected to, in addition to all of these tests, is something that I really couldn't find an infographic for, and something that are a little bit difficult to show. So 5G, absolutely. ISA, hazardous chemicals. So in case you have a corrosive environment, ISA certifications will make sure that your stuff is going to work, seamlessly, even if you have a lot of particulate emissions. If you have, corrosive gases like hydrogen sulfide, like HCl, you've got chlorine, you've got ammonia, and so on and so forth, which are pretty bad for your electronics. Then you have ICX and ATX ratings. Now, this is when you turn on your machine, maybe you have a motor which generates a spark, you want to run that, okay, in a minefield or in a mine, right? Or in a chemical manufacturing plant, okay? You won't want that spark to ignite and, kind of create problems for you, right? So we've got those ratings as well. We're probably one of the few people who have those kind of ratings, so you can use them when you're manufacturing inflammable, chemicals or products which use them. Then, of course, you have mil-spec rating, right, which allows you to subject them to these tortuous conditions. In addition to that, you also have marine ratings. So you want to put them in an oil rig, you want to put them, in a submarine, you want to put them in a ship, rolling motion, pitch, yaw, all of that is taken care of. You want to mount it in a vehicle, that's taken care of as well, okay? So you've got a bunch of ratings that actually ran out of space to basically put those icons here. And this is not just for notebooks or clients, it's there for servers as well, okay? You can pretty much run them at any edge with the confidence that they're going to run, and they're going to run with the built-in security that we have in there. Now, Noodle AI is one of the many, many AI partners we work with, and they are correlating almost a million data points to improve quality and operational efficiency of a steel mill, okay? So very quickly, can we have this data, please? This video, please.
The fourth industrial revolution is happening now in businesses everywhere. We see it with innovations like IoT-based machine monitoring, machine vision, AI-powered robots, cloud-based SCADA systems, and augmented and virtual reality. But what does it take for technology to unlock innovation, compress time to market, and create operational efficiencies? Next-gen solutions from Dell Technologies and Intel power the industrial Internet of Things to put data to work where it matters, when it matters. Our engineering talent is ready to help you jointly develop solutions to meet your unique
Is
requirements.
this the right video?
And with technology designed for industrial environments, you can deploy a new class of IoT and edge.
This is not the right video. Can you play this one, please? Sorry about that.
AI is going to help us solve some of the world's most vexing challenges. It's going to help us educate our children better, produce and distribute products better, all with a lot less waste. Noodle AI is an enterprise artificial intelligence company. We worked with Dell Technologies to design a new AI platform that provides real-time recommendations to companies, then turns those recommendations into action. The edge-to-edge system senses and learns, and then it improves manufacturing efficiency, quality, reliability, and safety.
Our objective at Big River was to operate the world's first learning steel production facility. Noodle became very involved with the upfront design work and data mining. In our first year of operation, we analyzed well in excess of 300 million data points. We look for correlations everywhere in the mill.
Big River Steel is setting all kinds of operational benchmarks, and the rest of the steel industry is really paying attention. With these products, we have the power to transform every industry worldwide. Pretty soon we're going to have 9.8 billion people on the planet. We need to make much better decisions in how we make things and move things. AI can help us do that.
I'm sorry, there is a typo here. It's not 800K, it's 800M. So it's almost a billion information points that we get from our edge gateways. We push them into our hyperconverged infrastructure, into our servers armed with accelerators, and we process all of that information to optimize your manufacturing processes. So here's another quick example of how we can have a low latency network of sensors and actuators improve and streamline, okay, your manufacturing process. So while this slide is very, very self-explanatory, I'll just take a quick minute to go through it. So what you see here is the production of an engine block. Now, very high performance engines will require extremely low tolerances because even a slight imperfection in the combustion chamber can result in, can compromise the longevity of the engine, right? So what we do is we take hundreds of photographs, of very high resolution photographs using cameras, and then we analyze them through an AI machine learning algorithm to predict whether this engine is going to meet those tolerances, whether it's going to be smooth, how, whether it's going to be, whether it meets those quality parameters and those tolerances. Similarly, we spoke about welding, right? When it's just too bright for the human eye to see, okay? You could have robots looking at thermal imaging, infrared cameras, to basically, with a lot of filters, to basically optimize the welding process. So machine vision is something that we do very extensively with a bunch of our partners. Similarly, electronic manufacturing. I mean, you've got PCBs being churned out at a rate of a few tens of devices, PCBs per second, right? So you want to make sure whether the PCB has been produced properly before you put it into an end device, into a TV, or perhaps even more importantly, into, let's say, a defibrillator, right? You wouldn't want that to fail because you wouldn't want, you'd basically be losing lives in case a defibrillator doesn't work properly. Or a CAT scan machine, you wouldn't want incorrect diagnostics to happen. So all of that basically happens at a very, very rapid scale when you use something like machine vision, right? And this is what you see, a broken path, okay? A path which basically is sort of not etched properly. So if you pass current through it, it will probably melt, compromising the circuit. With that, there's another very, very interesting video that I wanted to show you. This is with Brembo, okay? So they use our HCI infrastructure and our sensors for predictive maintenance to make sure that their assembly lines are running 24/7 and meeting production targets without compromising any quality, okay? And Brembo is one of the leading manufacturers of brakes for high performance vehicles, Formula One vehicles, and a host of other applications, okay? Can we please have the video, please?
Brembo is a leader in brake system for car, motorbike, commercial vehicles, and original equipment, aftermarket and racing. My team has to assure service level of a solution that the business required. The main target for IT organization are quality, service level, and to assure a dynamic and resilient infrastructure. IoT development in Brembo is focused on getting information and data from a PLC machine. We have to understand the value of the information that we collect, how to manage the quality process or maintenance process or assembly process. It's very important to understand the tooling consumption and top the machine when the tooling is not consumed. To do this, we have to analyze the big data coming from machining. The IoT infrastructure for us is very important because we are able to get in real time the efficiency of each line around the world. We are able also to make predictive maintenance on the machine in the future. What we are starting to see is a new relation between human and IT solution.
We are today in the Curno passenger car caliper plant, and I'm gonna show you how the IoT has helped us in recent years to improve our production. All of our machinery in production is connected to the Brembo network. Thanks to the IoT technology, we are able to get real-time data about our equipment so that we have all the information we need both to control production in real time and to perform historical analysis on the data. I have a dashboard with the department and how it's going, the lines that are getting produced at the correct rate and those that are not, and has our process engineers to improve our products and our processes by analysis of the big data that we collect. In this dashboard, we have summarized all the information that an operator or production manager needs to know how the line is performing during the current shift.
Dell support is critical also for new technologies that we are implementing in our infrastructure. With the help of Dell, we are able to consolidate this new technology and reduce the time of ramp-up of the solutions that are based on this new technology.
Thank you. So that was one of our partners, Brembo, and braking systems, I would put them, at a significantly higher, priority than the engine in my vehicle, because I would definitely want it to stop properly. Very quickly, the whole thing that we just saw in the video summarized: predictive maintenance, connected sensors to make sure that before something fails and impacts your production lines, okay, we've got that sorted. Very quickly, we spoke about Industry 5.0. I just want to very, very quickly touch upon it. We're looking at things where humans and robots are going to coexist, okay? And for that, it is very important that we crunch data in the shortest time possible, because the robot and we human operators, our colleagues, would be sharing the same space. So it is very important to equip the robots with the kind of machine vision that enables them to not inadvertently harm or injure their human co-workers. So Here's a very quick slide. It basically tells you our end-to-end portfolio. So it's not just servers, it's not just notebooks, it's not just hyperconverged infrastructure, it's a lot of gateways which allow you to run things at pretty much any edge possible. And you've got a bunch of industries where we've already deployed these products. In case you want to run things at the bleeding edge, you can pretty much put standard stuff which can run in a data center, and you can plonk them into a rugged modular data center, okay? Otherwise, which can run stuff between -40 to +55 degrees centigrade. It's IP65, fire suppression, fire retardant, everything autonomous, okay? And at the same point in time, you can run accelerator optimized servers at up to 55 degrees centigrade, okay? And then you can run stuff like these at up to 60 degrees centigrade. So pretty much any edge that you want to run things at. Very quickly, this is for from Halliburton, one of our premium customers, and I remember that we've done a project for an Indian company with them. Very quickly, can we have this this video as well, please?
Halliburton, Landmark, provides industry-leading petrotechnical software and service capabilities in the upstream oil and gas industry. Landmark is partnering with Dell EMC on multiple digital transformation solutions. One of them is a cloud solution, what we call the Landmark Earth Appliance. Landmark Earth Appliance is a unique combination of the converged and hyper-converged infrastructure capabilities from Dell EMC based on the latest VxRail technology from Dell with their PowerEdge servers and Dell networking components. And we take that and we put our industry-leading petrotechnical software, DecisionSpace 365, on top of that. So what that creates is a cloud solution for customers that no one else in the industry can offer, that is very fast time to value, very high reliability, very fast performance. Another area where we're offering digital transformation opportunity is in what we call voice of the oil field. So we'll have sensors on the different components out in the oil field to provide a capability for customers to be able to see and understand what's going on in their field. This is made possible by Dell EMC capability that we call the Landmark Field Appliance. The Landmark Field Appliance is a Dell Edge gateway that allows us to do analytics at the edge based on these sensors.
The appliance itself is a Dell computing platform that includes the Landmark digital platform pre-installed. We have the ability to store data on that device and forward back to the cloud. We have the ability to receive that data in real time, and we can run real-time analytics. So there's instant visibility across the organization, really integrating the oil field end-to-end from the sensors and actuators on the field all the way to the office.
I've described it as being a perfect storm of technology. It allows us to work with customers to save costs, to drive up productivity, to improve efficiency across the entire life of a reservoir. From an innovation standpoint, we're at a point now where we can model reservoirs on a software that can be deployed into the cloud, dynamically updated, almost in real time, analyzed, so that when I see an issue with my production, I can make a much better, faster decision, enhancing the life of the asset over time.
Through partners such as Dell Technologies, the ability to be able to listen to the voice of the oil field is fundamentally changing the efficiencies and the way you work in the oil and gas companies today.
So with Halliburton, you saw what we could do when we integrate that incredible portfolio that we showed you, which is probably the only, we're probably the only IT infrastructure provider who has such an incredibly diverse portfolio. So the power of integrating all of that HCI with IoT Edge Analytics is something that Halliburton has been using for a lot of these customers. Now, we spoke about SCADA in the previous discussion. So here's a very, very quick overview in terms of how you can use SCADA and realize it with Dell components, starting with the gateways, rugged machines, and then, of course, storage and HCI. Okay. Now, this is the last video. This is also something which is very, very interesting. It looks at machine vision. And I know that manufacturing can't run without logistics, right? We need to feed our factories with raw material, and we need those factories to produce those materials, and then of course we need those materials to be transported reliably and quickly to consumers who are actually paying for them. Quickly, can we have this video, please?
Our latest generation of tech involves what we call a railcar inspection portal. We have our systems that capture images from all four sides of a freight train at speed, analyze that data using our AI algorithms. Our technology systems are deployed at the edge to optimize the capture of the image data onto the power edge servers that we utilize, the network infrastructure, as well as the power vault system, and also do all of the AI processing. We've developed these portals that essentially include a mini data center that sits trackside.
We here at Duos, we basically built a data acquisition system where we capture image data, vibrational data, laser data, LiDAR data. We started experimenting with AI and we were getting 95% accuracy. From then on, we dived solely into AI. The complexity is that we need to process all the data within 5 minutes of the train leaving the portal and transmit it to the customer, because there might be a defect that can cause a derailment and they need to stop the train right now. We build our own platform which does everything from image acquisition to model versioning to deploying it at the edge. You're seeing a tremendous result. The acquired data is usually stored at the edge. I need to be able to transfer and analyze the data quickly. You're talking about throughputs of hundreds of megabytes per second. We can grab the data off of any of the machines, any of the camera acquisition servers, shoot it off into our AI processing server in a matter of microseconds. The future of our portals and the future of the AI within our portals is unlimited. You want to do it in real time at track speed, and the speed keeps increasing.
Dell offers the best mix of solutions and service and support. Because our applications are unique, especially involving the AI, it's very hard to find providers that can provide us with hardware to perform at the level we need it to perform.
So that was a live example of, pretty much using our end-to-end portfolio of products at any edge. So this is, there's a lot of vibration going on over there. There's a small, micro DC there, which houses all of these components. And they're actually components which are meant to be used, some of them are meant to be used in the confines of a data center. So they can't really run at beyond 35 or 25 degrees centigrade, but we still have the capability to create custom enclosures and deploy them where conditions are far, far, far from optimum. Very, very quickly, of course, this is how the entire chain comes together. So you have connected manufacturing, you have raw materials which are being brought just in time. Dell is a pioneer in just-in-time manufacturing. We've been doing that. It's a part of our DNA. We were the only company to actually do that from an IT point of view, okay? And we use all of those technologies that we manufacture in our own production environments. We use it to ensure that raw materials reach our companies on time. We make sure that they're shipped, the finished products are shipped out of those manufacturing locations on time. We help companies like Airbus Industries to sort of build products across multiple locations in Europe, okay, where parts of the aircraft are built in France, some of them are built in the UK, some of them are built in Germany, and so on and so forth. So all of that gets, comes together through the use of sensors and actuators. Okay, here's a very, very quick overview of some of our ecosystem partners in case, some of you who do business with us have been left out, my apologies, but I was really in a bit of a hurry, so this is not comprehensive by any order. Now, very quickly, a lot of customers come to us and say, hey, what is Edge really all about? And must I put in so much time and effort to actually make a start? So what we did was we came up with, an Edge maturity model, okay, where we said at the end of the day, what you're going to be doing is connecting PLCs over a network, right? So you start with sensors, which gather data, you analyze that data, and you basically send information in as real time as possible to actuators to basically automate your process. So this is something very, very rudimentary, okay? But then what if you want to replicate it at other locations? What if you really want to use that information to maybe do some sort of optimization, real-time analytics? So then you move one step further and you work with a repeatable model where you put in something which is accelerator optimized, okay? You have some more storage, okay? You put in a bigger switch, okay? The edge gateways are there, they do a lot of cool stuff, okay? And then later on, if this is really working out for you, you can build stuff more. You can put in a dedicated storage. So one of our power store arrays, you can basically crunch data on those arrays, okay, and save on compute. And then, of course, you have accelerator optimized servers like the R750XA, which can run up to 4 300-watt accelerators in the same machine. And then, if you want to really go the whole hog, you want to integrate your SAP system, okay, then you can basically get more storages, even more acceleration, okay. You can use our edge servers, okay, augment the capabilities of these edge gateways, which are wirelessly connected. They support pretty much all formats of wired and wireless communication, okay, and then basically crunch it right there and then. Now, what is really happening? You're computing more, you're processing more information, and you also have the capability of integrating ERP, okay? Finally, these are the only two slides which are product specific, okay? One is a great, great platform that we are very proud to have launched earlier last year, okay? It's based on our partners, Intel's 3rd generation of Xeon CPUs. You can run these servers from -5 to +55 degrees centigrade. You can use them for any industry, and most importantly, they are incredibly secure. So you will get the same level of security that you expect from us at our data center, so in our data center server portfolio, to pretty much every single device that we send at the edge, okay? These are just a few of them. And then, of course, these are probably one of the few machines that can run at up to 10,000 feet. Also, this is the last slide, our edge gateway portfolio, which supports RS-232, CAN bus, RS-485, RS-422, okay, PoE, DO, pretty much everything. This MIL-810G can run it up to 60 degrees centigrade, and you can basically have almost every possible wireless technology here that you can think of, okay? So pretty much in any configuration, completely fanless. With that, thank you so much for being patient and your support. You all have a great day. Thank you.